We all know the feeling. You're doing something. Walking, washing dishes, maybe trying to sleep. And suddenly a tune loops in your head. It's catchy, sometimes annoying, sometimes comforting. Scientists call this involuntary musical imagery, or more informally, an earworm. In this episode, we'll follow the neuroscience, psychology, and simple behaviors that make a melody stick. And we'll end with practical tips you can use when you want a tune to stick or want it to stop. First, earworms are normal. Nearly everybody experiences them. They're not a sign of pathology, they're a sign of a brain that's constantly predicting, compressing, and replaying sensory patterns. Music is especially well suited to this because it's structured, repetitive, and rich in rhythm and melody, all features the brain's predictive systems love to loop. Let's break the phenomenon into parts. Two broad mechanisms explain why some songs loop. 1. Encoding and salience. How the song grabbed attention in the first place. And 2. Spontaneous replay. Why the brain chooses to rehearse that memory again and again. Encoding and salience. A tune becomes memorable when the brain flags it as significant. That flag can come from many sources: novelty, emotional arousal, repetition, or context. Hearing a song at a high arousal moment, a first kiss, a big game, a shock, creates an emotional tag. Emotional tagging makes memories more likely to be replayed. Likewise, novelty and predictability interact. A melody that balances surprise and expectation, a catchy hook, is easier for the brain to model and therefore to replay. Repetition, of course, strengthens encoding. Commercially successful earworms are designed to repeat a short, distinctive hook many times. But attention also matters. If your mind is lightly occupied, doing a routine task that doesn't require heavy cognitive control, it's more likely to wander and to retrieve cached auditory loops. That's why earworms often start while you're showering, commuting, or doing chores. Now, spontaneous replay. The brain is a prediction machine. It builds compressed internal models of sensory sequences, including music. And it uses replay to maintain and refine those models. When the internal model is incomplete or uncertain, the brain may fill in the pattern by replaying it. Short melodic fragments with strong rhythmic anchors are easy to predict and then easy to get stuck on. Another important factor is verbal hooks. If the melody has an attached lyric phrase that's simple and repeatable, the verbal loop helps sustain the musical loop. Similarly, musical intervals and rhythms that match speech-like patterns are more memorable. Cognitive load plays a role. If you're cognitively busy, solving a math problem or reading a demanding text, you're less likely to experience an earworm. If you're doing repetitive manual tasks with low cognitive demand, those spare cycles make room for involuntary musical imagery. That's one reason musicians themselves often report fewer intrusive earworms while they're actively playing. Their cognitive resources are occupied. So why some songs and not others? There are a few predictable features. Short, simple melodic motives that repeat. Distinctive contour. An interval or turn that sounds unique. Predictable rhythm with a clear beat. High exposure. Songs heard more frequently, advertising jingles, chart hits, are statistically more likely to be retrieved. Emotional or situational tagging. Hearing a song during a marked event. Consider the classic advertising jingle. They are engineered to be earworms, featuring a short, simple melody, a predictable rhythm, and a lyrical hook that repeats a brand name. This is combined with massive exposure. The jingle checks all the boxes: repetition, simplicity, and high exposure, making it almost inevitable that it will pop into your head later. Brain imaging studies show that earworms recruit regions involved in auditory perception, motor planning, and memory, not surprisingly. The premotor cortex and supplementary motor area are often active, which is why you sometimes tap an imaginary rhythm. The default mode network, the brain system that activates during mind wandering, is also involved, which fits the phenomenology of earworms emerging when we are internally directed. These activations reflect the mixed nature of earworms, a perceptual replay combined with motor resonance and memory rehearsal. There's psychological nuance too. Some personality traits predict susceptibility. People who score higher on measures of openness or musical engagement may experience earworms more frequently. Conversely, people with very high working memory demands at baseline can have fewer spontaneous loops. Their minds are less available for idle replay. Let's talk about the stuck part. Why does a loop repeat rather than finish? A simple answer comes from predictive coding. Think of your brain as trying to compress the tune into a short model. If the model is incomplete, if the brain hasn't resolved the full phrase, it will keep replaying the fragment, trying to predict the next notes. Some hooks are partial phrases that invite completion, so the brain keeps looping until either the phrase is completed, you hear the song, or your attention changes. Practical strategies follow directly from the mechanisms. If you want to stop an earworm, 1. Introduce a replacement. Play another song with a clear ending. A strong, complete musical phrase can satisfy the brain's prediction and stop the loop. Research and practical reports often call this the cure song technique. 1. Distract cognitively. Engage in a task that requires focused attention. Solve a puzzle. Read a complex paragraph. Do arithmetic. Using working memory can suppress involuntary replay. 1. Complete the fragment. Sometimes listening through the whole song once ends the loop, because the brain's model is satisfied. 1. Sing or hum the ending. Actively produce the missing notes and then stop. Active completion can close the loop. 1. Chew gum? There's mixed evidence. Chewing and other oral motor acts sometimes reduce vivid musical imagery, probably because they interfere with subvocal rehearsal systems. 1. Try a sensory reset. This involves brief mindfulness. Stop, take a few slow breaths, and shift your attention to your other senses. Look around and silently name 5 objects you can see. This act of grounding yourself in the present can interrupt the internal auditory loop. If your goal is the opposite, make a tune stick, then invert the advice. Use short, repeatable hooks. Pair the tune with emotional or novel contexts. Rehearse it spaced over time rather than cramming. Spaced exposure strengthens retention. Use multisensory cues. Associate the melody with image or movement to create richer, more retrievable traces. There are interesting clinical angles. People with depression or obsessive tendencies can experience repetitive musical imagery that is distressing. Therapies that target intrusive thoughts, for example, cognitive behavioral techniques or mindfulness, can help. In extreme cases where musical imagery is disruptive, clinicians use strategies similar to those for intrusive thoughts: structured interruption and replacement, and training in attentional control. Another curious point: cultural exposure shapes the melodic primitives the brain prefers. A motif that is highly memorable in one culture may not be in another because of differences in scales, rhythms, and common melodic patterns. So earworms are partly cultural artifacts. Let's be clear about limits. Most studies on earworms are observational, experimental in lab settings, or use self-reports. We have converging evidence about mechanisms: attention, repetition, emotional tagging, and predictive coding. But individual variability is wide and simple cures don't work for everyone. Before we wrap up, quick practical toolbox: 5 evidence-informed tips you can use tomorrow. 1. If a song won't stop, play a short, satisfying cure song, one with a decisive ending, once. 2. When you want to memorize a tune, sleep on it, encode, then get a good night's sleep. Slow wave sleep helps consolidation. 3. For both stopping and starting, use focused cognitive tasks. A 10-minute focused read or mental arithmetic often breaks loops. 4. Use active completion. Hum or sing the missing phrase and then stop. That closure often ends rehearsal. 5. If it's persistent and distressing, track triggers. Note when the earworm began, what you were doing, and whether certain contexts, ads, apps, people, reliably started. Then manage exposure. Earworms are a small but revealing window into how our brains process patterned information. Prediction, compression, memory, and motor planning all in one short loop. They show that the mind is always rehearsing and testing models of the world, even when we aren't paying attention. So, to recap, earworms are born from a song's memorable features, and a brain in a state of low attention. The brain's predictive nature then latches onto incomplete patterns, creating a loop. To break it, you can either complete the pattern or disrupt it with a focused mental task. If you like this episode on the brain and behavior, subscribe for more careful, evidence-first explorations of everyday mysteries of the mind. We appreciate your time. Thanks for watching.